All right, we're looking at lesson 5.3, exponential functions. So we're going to be graphing our exponentials today. So we're given 2 to the x power, and they gave us a table here. So when we put a negative exponent, remember that the negative exponent means we take the reciprocal of 2, which will be 1/2 to the positive 3. 1/2 to the third is 1/8. Negative 2 gives us 1/4. Negative 1, 1/2. Anything to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. 2 to the third is 8. And we'll look at the rest of this in just a minute. Let's go on and look at number 2, 1/2 to the x power. So when I put a negative 3, the negative means take the reciprocal. The reciprocal of 1/2 is 2. And then 2 to the third power will be 8. So 1/2 to the negative 2 is positive 4. 1/2 to the negative 1 is 2. 1/2 to the 0 is 1. 1/2 to the first power is 1/2. 1/2 squared, 1/4. 1/2 to the third is 1/8. So when I graph these, I get mirror images of each other. To the left, I plotted the points. To the left, it's hugging the x-axis. It gets closer and closer to the x-axis here. To the right, it's going to infinity, going up very quickly here. You remember, each point is going to be twice as high as the point before it. Just a mirror image of that with 1/2. With negative 3, I'm at 8. With negative 2, I'm at 4. With negative 1, I'm at 2. Then 1, 1/2, 1/4, 1/8, etc. So as I go to the right, it's hugging the x-axis. Domain on both of these is all real numbers. The range on both of these goes from 0 to infinity. The difference is that the left graph is increasing for its entire life, and the right graph is decreasing for its entire life. For the end behavior, as I go far to the right here, as x approaches infinity, f of x approaches infinity. It's going up. As I go to the left, as x approaches negative infinity, f of x approaches 0. For number 2 here, as x approaches infinity, as I go far to the right, f of x approaches 0. As f of x approaches negative infinity, as I go far to the left, f of x approaches infinity. So I do have on both of these a horizontal asymptote at y equals 0 for both of these. Okay. So, exponential functions are functions of the form f of x equals b to the x power, where b is positive and b does not equal 1. If b is greater than 1, we get an increasing function. If b is between 0 and 1, we get a decreasing function. So first we're going to look at the increasing. b is greater than 1. And again, I already filled this out. We're looking at, for example, 2 to the x. We've already done this, so I just put in the values. We've already graphed it. Domain's all real numbers. The range from 0 to infinity has an asymptote, a horizontal asymptote at y equals 0. Okay? Characteristics of this. This is a one-to-one function. It is increasing over its entire existence from negative infinity to positive infinity. It has no x-intercept. And the y-intercept is going to be 0, 1. Okay? And that leads us right into this box right here. All exponential functions will go through 2 points. They'll all go through 0, 1. And they'll all go through the point 1b, whatever b is. If y equals b to the x, if I put in a 1 for x, I get b. Okay? So now we're looking at the situation where we have the decreasing when b is between 0 and 1. So our example is 1/2. Again, we already did these values. We already graphed this. The domain's all real numbers. The range from 0 to infinity. Asymptote, y equals 0. And it's going to be very similar. It is also a one-to-one function. This one is decreasing instead of increasing. It is decreasing over its entire existence from negative infinity to infinity. It again has no x-intercept. And the y-intercept once again is 0, 1. And that's still going to be true. Whether it's increasing or decreasing, this part's going to be true. It's always going to go through 0, 1. It's always going to go through 1b. All right? Okay, so let's look at some transformations then. Graph the following transformations of f of x equals b to the x power. So our first one, we have negative 5x to the negative 2 power. So I've got this negative in front. That tells me it's going to have an x-axis reflection. The minus 2 here tells me it's going to be shifted to the, you would think minus 2 would go 2 to the left, but this is going to go 2 to the right. All right, and I'm going to make a little table here just for 5. And I don't need a lot of points. X, 5 to the x. So if I put in negative 1, I get 1/5. If I put in 0, I get 1. If I put in 1, I get 5. And that would really be good enough. Okay, so I'm going to shift 2 to the right and have an x-axis reflection. So at negative 1, I would have been at 1/5. I'm going to go across the x-axis and then 2 to the right. That puts me right here. 0, 1, x-axis reflection flips me down here, and then 2 to the right puts me here. 1, 5, 1, and then up 5. Well, I'm going to flip that over the x-axis. I'm down at 1, negative 5, and then 2 to the right puts me right here. So what's going to happen is this is going to hug the x-axis still, and then it's going to take a quick turn and look something like that. All right, my domain on all of these is going to be all real numbers, except possibly on word problems where, you know, for some reason we're limiting the domain. The range in this case is going to be from negative infinity to 0, since we flipped it upside down, and the asymptote is still going to be y equals 0, but now instead of being the bottom of the graph, that's now the top of the graph. Okay, let's look at the next one. I've got 2 to the negative x power minus 3. So that negative in front of the x, that gives a y-axis reflection. And then the minus 3 here is going to shift 3 down. All right, so when the minus or plus is up on the exponent, it goes left and right. When it's behind the whole function, plus or minus, that's going to shift up and down. Okay, so let's do a little table. I'm going to do 2, actually x and 2 to the x. So if I put in negative 1, I get 1/2. If I put in 0, I get 1. If I put in 1, I get 2. And I'm going to go and put 2 and 4 here. Okay? That should give us a pretty good idea what it looks like. So at negative 1, I'm at 1/2. I shift it, go across the x-axis, across the y-axis, and then 3 down. 1, 2, 3 puts me here. 0, 1 would be here. Cross the y-axis doesn't affect that. Shift 3 down. 1, 2, 3. 1, 2, 1, 2. Go across the y-axis and then 1, 2, 3 down. 2, 4, 2, and 4 go across the y-axis to negative 2, 4, and then 1, 2, 3 down. Okay, so I'm going to have an asymptote at negative 3. So this thing's going to hug this asymptote and then turn. And actually, you know, if I put in 3 here, I would have had 8 minus 3 is going to be 5. So at negative 3, it should be going through 5. There we go. That's a pretty good looking graph. Okay, negative infinity to infinity. This time my range is going to be from negative 3 to infinity because of the shifting going down 3. And my asymptote is y equals negative 3 again because the shift down 3. Moving on. F of x equals 2 times 1/3. Well, let me say one last thing that while I'm thinking about it, about this problem. 2 to the negative x minus 3, let me just write a little note here. This would be exactly the same as 1/2 to the positive x minus 3. Because if I took that negative and just took the reciprocal, I get 1/2 to the positive x. And so that's why it's decreasing instead of increasing, even though it's a 2 here. Okay, that negative exponent does the y-axis reflection, which is the same as basically taking the reciprocal here. Okay. 2 times 1/3 to the x plus 4 plus 2. So this got a lot of stuff going on. So I've got a vertical stretch times 2. I've got a plus 4 here is going to do a shift of 4 to the right, left, going 4 to the left. Plus 4, you would think 4 to the right, it's going to go left. And then I've also got a shift of 2 up, the plus 2. All right, I'm going to make myself a little table here. X, 1/3 to the x. If I had negative 2, I'd have 9. If I had negative 1, I would have 3. 0 is 1, and 1 is 1/3. Okie doke. And then I'm going to, so I'm going to multiply each of these times 2. So for example, if I put in 0 here and get 1, then I'm going to have 2 times that. All right? So let's just go through. So at negative 2, I would have been at 9. I have a vertical stretch times 2. That's going to put it way off my graph. So actually, I'm not even going to graph that. Let's start negative 1, 3. I'm going to do a vertical stretch times 2 to get me to 6. I'm going to go 4 left. 1, 2, 3, 4. And I'm going to go 2 up. 1, 2. And that puts me right there. 0, 1. Vertical stretch times 2 puts me up at 2. 4 left. 1, 2, 3, 4. 2 more up. Puts me right here. 1, 1/3. Double that. I'm going to be at 2/3. I go 4 left. 1, 2, 3, 4, and 2 up. Be right here. My asymptote will be at y equals 2 because of the shift of 2 up. So it's going to hug that thing going to the right, and it's going to turn pretty quickly here, going up. Okay? Domain is all real numbers. My range now is going to be from 2 to infinity. My asymptote, y equals 2. All right. I'm going to rewrite this a little bit. I'm going to say the negative of x minus 4. X minus 4, and I'm going to take the negative of that. Okay, hope this works out okay. So I've got a y-axis reflection. And I've got a shift of 4 to the left. Excuse me, shift 4 right. That works. And I think that's about it. So let's make a little table here. I'm going to have x. I'll have 4 to the x power. Negative 1 would be 1/4. 0 would be 1. 1 would be 4. And by the time I get to 2, I'm way off the graph at 16. So if I do negative 1 is 1/4. I have a y-axis reflection. It's going to reflect across here to positive 1/4. and then, positive 1, 1/4, and I'm going to shift 4 right. 1, 2, 3, 4. So it puts me at 5. If I put in 5 here, I get -1. That looks right. If I put in 0, I'm at 1. Y-axis reflection does not affect that. 1, 2, 3, 4 to the right. Puts me right here. If I'm at 1, 4, I reflect across the y-axis, and then 1, 2, 3, 4. Okay, there was no shift up or down, and so my x-axis is going to be my asymptote. I'm going to turn this thing just so I can draw this a little easier. So there's my graph, my exponential function, my domain, all real numbers, my asymptote, x-axis, y equals 0, my range, 0 to infinity. Alrighty? Last two here are asking us to kind of reverse the situation, write the function for the following graphs. Okay, so notice I've got an asymptote. I'll just write a couple notes here. I've got an asymptote at y equals 2. It's going through, this is going to be like my 0, 1 point. If that's my asymptote, then that's going to be like my 0, 1 point. And so I've shifted, if normally that's the x-axis, I've shifted 6 to the left. Okay? And then if this is my b value, if this was 1, 2, 3, 4, 5, it looks like 5. It's going through the point, if this is my 0, 0 here, then it's going through the point 1, 1, 2, 3, 4, 5. So I think that my base equals 5. So if that's the case, f of x equals 5, to shift 6 to the left, I'm going to say x plus 6, and then I'm shifting up 2 plus 2. And I think that should do it. So if I put in -5, -5 plus 6 is 1, that's 5 plus 2 is 7, it's going through the point -5, 7, and that works. Okay? Number 8, last problem. I've got asymptote, which indicates the vertical shift at y equals -5. So my point here is my 0, 1 is right here. And so if this was normally the y-axis, I'm shifted 4 to the right. Okay, so I've got a shift of down 5, I'm going 4 right, and it's going through this point here, which is 2, 4. I know the basic shape of the equation will look something like y equals b to the x, since it's 4 right, minus 4, and then down 5, minus 5. And so what I'm going to do is I'm going to plug in 2 and 4 for x and y. 4 equals b times 2 minus 4 to the -5. If I add 5 to both sides, I get 9 equals b to the -2. So I'm going to do the -1/2 power on both sides to cancel out my -2 here. And I get b is equal to 9 to the -1/2. The negative tells me to take the reciprocal, 1/9 to the 1/2. So I want the square root of 1/9. And b is equal to 1/3. All right. So my equation, f of x equals 1/3 times x to the x minus 4 power minus 5. Okay, so we just plug in a point, and we could have done that over here as well. Number 7, we could have plugged in this point. We could have said, all right, I'm shifting up 2 and 6 to the left. I know it's going to be b to the x plus 6 to go 6 left, and then plus 2, and we could have plugged in this point, -5, +7, and so 7 equals b, -5 plus 6 plus 2. And if I subtract that 2, I get 5 is equal to b to the first. And so sure enough, my b value is 5 there. All right. Okay. If you have questions, let me know. Otherwise, I will talk to you tomorrow. Bye-bye.